Hello everybody, Todd again. More proofs. Right now we're working on this problem here. Prove Q if and only if F. Looking at the premises, we don't see any biconditionals whatsoever, so we're going to have to make our Q if and only if F through the rule material equivalence, and we have two options. We can either look for Q and Q then F and F then Q, or we can look for Q and F or not Q and not F. What I see is we have a Q then F and an F then Q. So those are the pieces that we're going to use to make our biconditional. The F then Q is ready. It's the Q then F that's the problem. We need an A and a C to do a modus ponens on line 1. There's an A and C in line 2, but we need to get it out. First things first, since the main operator is a conjunction, let's get rid of that D. So 5 is B or A and C from 2 by simplification. Okay, remember we're after the A then C part. We have an OR on line 5. The main operator is an OR, so we need a not B to get to the A then C. Fortunately, we have a not B on line 3, so 6 is just A and C from 3 and 5, disjunctive syllogism. Now with that A then C, let's think about line 1 again. We can get Q then F, that's 1 and 6, modus ponens. Okay, so we have the two pieces we need, the F then Q and the Q then F to make our biconditional. We need to put them on the same line, so that's F then Q and Q then F, and that's from 4 and 7, and that's conjunction. And now we can get to Q if and only if F from 8 by material equivalence. All right, let's try another. Okay, here we go. Q or not Z. Okay. So the first thing, we can look for a Q or not Z together, and we don't see that. So we might look for its opposite in an antecedent. We don't see that either. So that's when I really start thinking about what the main operator is. In this case, it's an OR. So since it's an OR, I think about two different strategies. Strategy 1 is get one of the disjuncts, like a Q, and then add the other. Or I can get this second one, add the Q, and then do a comm and get to what I need. So that's one thing. Just get one of the disjuncts, add the other. The other thing to think about is to be on the lookout for the following possibility. Suppose I see blank then Q and blank then not Z. Well, then I'm thinking that a constructive dilemma is going to be the answer. And look what I see. I see a blank then Q, and I see a blank then not Z. So I'm pretty certain that we're going to do this problem. The key is constructive dilemma. Let me get those two parts. The blank then Q is ready. The blank then not Z needs to be extracted from line 3, which is easy enough to do. This is a conjunction. Line 3 is a conjunction, so let's just move the right conjunct over to the left side, and vice versa. That takes place by comm. And now we can simplify to Z or C then not Z from 4 simplification. So now I have my two parts for my constructive dilemma. And so now I need the appropriate disjunction. I need the box or circle. So let me see. I need a C or not B. Now, I don't seem to have that, but I think there's one hiding right here in line 1. Let's break off the B, then the C from 1 simplification. And what I know is I can convert thens to ors, so this becomes not B or C from 6 by implication, material implication. And that is exactly what I needed to do my constructive dilemma. Look at line 2, line 5, and line 7. If you look at those 3 lines, you get Q or not Z, 257 CD. Okay. All right. Lots of extra lines left here, which means there's probably another way to do it that's much longer, but this one worked out just fine. Okay, let's move on to our next one. Okay. Prove R and X or R and Y. Well, certainly I don't see anything that big in the premises or its opposite in the antecedent. One of the things that I am looking at is that an R is spread across a disjunction, which makes me think that we should consider the distribution equivalent. So that would be R that'd be R, oops, let me just get rid of that. The R has been distributed to the X and the Y. The minor operator becomes the major operator, and the major becomes the minor. So this is what this looks like after distribution. So if I can get to this, I can get back to what I need. And I notice I have an R, so all I really would need is the X or Y. And notice what's in the consequent of 2 conditionals, X and a Y, which makes me think, just like the previous problem, that we can use CD to get to this disjunction. So let's get those parts from 1 and 2 and figure out the rest momentarily. So A then X from 1, simplification. We can do that because the main operator is an and. And line 6, we have B then a Y from 2, simplification. So now what we need is a disjunction, A or B, which we have right in line 3. And we can also pull that out easily because it's a conjunction, A or B from 3, simplification. So look at 5, 6, 7. That's the perfect setup for X or Y, 5, 6, 7, CD. So now I've got the 2 parts I had talked about early. Let me just put them together. R and X or Y from 4 and 8, conjunction. And this, the R can be distributed to the X, to the Y. Main operator becomes a minor. Minor becomes the major. That's 9 by distribution, and we're done. Okay, I think we have time for one more. Not R. Not R is what we have to get to. Only place we have the possibility of a not R is on line 4, which means we need the opposite of the consequent. We need P and Z to do a modus tollens. I don't see P and a Z, and remember this is a conjunction, so if I get a P and I get a Z, I'm good to go. I can just put them together. Now take a look at line 5, and let's do a De Morgan's on 5. It becomes P and Q from 3 by De Morgan's, and that's helpful because after all we said we needed a P, so let's just get it before we forget. P from 5 by simplification. All right, so he also needed a Z, we said. There's a Z, but it requires a whole bunch of junk to get. A or B or not J. It doesn't look like we have that, but notice that these are all disjunctions and we have an A, which means we can add all the stuff we need. So first step, A or B from 1 by addition. And then using 7, A or B, we can add or not J from 7 by addition. And now this is the antecedent for line 2, so we can do a modus ponens 2 and 8 and get Z, 2, 8 modus ponens. So now we have those two parts we were talking about, the P and the Z. Let's put them together. P and Z, 6 and 9 conjunction. And this, line 10, is the opposite of the consequent in line 4. So we can do a modus tollens and get our not R.